Intermediate Algebra Section 11.2. When the terms of an arithmetic sequence are added, an arithmetic series is formed, and we have the following formulas for the sum of the first n terms of an arithmetic sequence. S sub n is found by taking n, the number of terms, divided by 2, times the sum of the first term plus the last term in the arithmetic sequence, and substituting the nth term formula into this gives us another version for the series or the sum of an arithmetic sequence of a finite or specified number of terms is n over 2 times the quantity 2 times a sub 1, the first term in the sequence, plus n minus 1 times the common difference. And let's take a look at an example of that. Using that formula, they're asking us to find the sum of the first 20 terms in this arithmetic sequence. So, just to verify we have an arithmetic sequence, we can clearly see our first term is 2. Our common difference, 6 minus 2 is 4, 10 minus 6 is 4, and so on. And they want us to find the sum of the first 20. Well, we have two options. We can either generate all 20 terms by continually adding 4 until we have 20 terms, or we can use one of the two formulas that we just wrote down for the sum of the first n terms is found by taking n over 2 times the quantity twice times the a sub 1 or first term plus n minus 1 times the common difference. So in this problem we're after the 20th term, so we'll take 20 in place of n over 2 times the quantity 2 times the first term, which is 2, plus n, which is the 20 that we're looking for the sum, times the common difference we found to be 4. Simplifying this, 20 divided by 2 is 10. Simplifying inside the parentheses, we have a 2 times 2 is 4. 20 minus 1 would be 19, and we have a 19 times 4, which ends up with a 76. Adding inside, 76 and 4 is 80, and 10 times 80 turns out that the sum of the first 20 terms in this arithmetic series is 800. The next one is asking us to find the sum of the first 100 positive even numbers. Well, let's see what that would look like. Positive even starts with 2. We would have 4, 6, and so on up into our 100th term. And to do that, when we're after the 100th term, and we could determine what that 100th term is by using the formula, or if we use the series formula that we just used in the previous problem, S sub n is equal to n over 2 times twice the first term plus n minus 1 times the common difference. We don't need to know exactly what that 100th term is. Imagine you can figure it out pretty easily. We have a common difference of 2. 4 minus 2, 6 minus 4 is giving us a common difference of 2. To find then the sum of the first 100 terms and replacing the variables in the formula, n is 100 over 2 twice the first term. We have n, which is 100 minus 1 gives us 99, and we are timesing that by 2, our common difference. Simplifying, we end up with 100 divided by 2 is 50. 2 times 2 is 4. Skipping the addition and jumping to the higher priority of multiplication, we have 99 times 2 is 198. Simplifying further inside the parentheses, 4 and 198 add up to be 202. And finally multiplying, it turns out that when you add the first 100 positive even numbers, the sum is 10,100. In this next problem, they're asking us to find the sum of all the multiples of 7 from 7 to 700 inclusive. So we would have 7, and a multiple of 7 would be just a matter of adding 7 to the next number. That would be 14. Adding 7 to that is 21, plus all the way up to 700. So we can see that our first term is 7. We can find the common difference here because of the fact it's a multiple of 7. We have a common difference of 7 in these numbers. But how many numbers are we adding together? Now, some may be able to identify what number 700 is. We have our first term, second, and third. What is that? But if that's not clear, we can use our nth term formula. The nth term in an arithmetic sequence is found by taking the first term plus n minus 1 times the common difference. Well, we know what that nth term is. It's 700. We know the first term, which is 7. We don't know what n is, but we know the common difference is 7. Simplifying this formula or equation, we'll do a distributive, so we'll have 7 times n is 7n, and 7 times negative 1 is negative 7. When we simplify on the right, the 7's cancel out. 7 minus 7 is gone, leaving 7n, and dividing both sides by 7, we end up with n is equal to 100. So if you already figured out that we were adding 100 terms, great. Otherwise, here would be how to find that. So the question then is asking us to find the sum of the first 100 terms. And this time, because we know our first and the last term, we could use that other version of the sum of an arithmetic sequence, which was given as n over 2 times the sum of the first and the last term. We could use the other formula because we know our common difference, but just to illustrate the use of this formula, we are adding the first 100 terms because of going to 700. So replacing n with 100. Our first term is 7. Our last term was given, which is 700. Simplifying, 100 divided by 2 is 50. Adding inside the parenthesis gives us 707. And then multiplying these two gives us the sum of the first 100 numbers in this arithmetic sequence with a common difference of 7 of 35,350.